You already know my name. You know that I'm from Poland. You know my Russian. 1, 2, 3, 4. That's still it. You know that I work for Semantis. You know that I have a Twitter, a blog, and you know that you can ask me questions. I would really value any feedback you will have, be it via email, via Twitter, personally, whatever. This presentation is meant to be a simple walkthrough, pretty much number of available tools, and it's geared to actually showing you what you have available. Okay. I have some prizes to give away for good questions. These are conference prizes and also my own. So there are 2 t-shirts because I'm affiliated with Geekon. I'm part of the Geekon team. By the way, if you're not coming to Geekon Prague or Geekon Kraków, you're missing a lot. So do come. We have Martin Thompson, we have Greg Young, we have other really very good speakers. And thus, you are hereby invited. Now, today we cover parametrized testing in a number of ways. We cover non-functional requirement, aka system testing, for all the following things here. It's very weak, but you can see it, right? This annoying red dot which jumps all over the place. And then there is the new JUnit and many other tools. We have like more than 11 tools, so forgive me for being brief on pretty much each of them. Yeah. In case of questions, raise your hand, shout at me, or wait till the end of the presentation, or tweet me, whichever works. Now, parametrized test here, I would like to cover TestNG, JUnit in like 3 different ways, 4 different ways actually. Then I will also mention property tests. So TestNG is something I would like you to actually take away from this presentation. Why? TestNG is around for quite some time. It's not as rigid as JUnit. It allows you greater configurability of your tests. It allows you chaining of your tests. It allows you to actually write your test as integration test, unit test, end-to-end test, and a number of others. It has nice features for grouping tests. It may be configured externally via XML file. There is a number of things you can do with TestNG which would be rather hard to do in JUnit, which is very likely the case why pretty much every company I worked with or for actually used TestNG when they wanted to do Selenium testing, not JUnit. Now, how does parameterized testing look here? First of all, you're creating a public object matrix method which may have any name as long as you annotate it with data provider and the name you want. If you will not use the name here, aka this one, then this name better should be the same as here. Because for each method annotated with test, you need to actually tell that you will be using a data provider. Now, when you specify that, you're able to actually take each parameter and pass it to method parameter. So this is fairly intuitive, okay? This is like all the setup that you need to do. Now with that, we are able to run a parameterized test, and we may reuse the data provider for pretty much any test we want. This brings us to another nice feature of TestNG, which is soft assertion. TestNG has soft assertions built in. Hands up who knows what soft assertion is. Okay, so soft assertion is actually sort of a collector. Okay. Imagine you have, okay, I'll borrow the very nice example of Asset J documentation. Imagine you have a murder in a room, okay, and you want to assert the situation. So you want to check that the chandelier is actually pristine, or perhaps it's bloodied, so we know the murder tool. You know to check whether the murder happened in the kitchen, or whether it happened in a room. You know, you want to check the number of your guests which are still alive. So these are like 4 assertions already. So you may actually check with just assertions, okay? Let's say that you just test the first thing that comes to mind when we want to check whether the murder occurred, whether the amount of guests still alive is the same after the party as it was before. So everybody is living. If you have that, then if somebody is murdered, that's all you know, because the assertion throws exception and the test execution is interrupted because exception went out. Now with soft assertions, you're running all the assertions one by one. So you're checking the number of live guests, you're checking whether colonel is okay, you're checking whether the professor is okay, you're checking whether the knife in the kitchen is missing or is not missing, and things like that. So with that, you're able to run number of assertions which all together are one large business assertion. The other way of doing that is to write your own custom assertion, or write your own method which actually runs all the assertions within and try to somehow aggregate the results, which is cumbersome. So TestNG has built-in soft assertions which you use like that. Okay, and then you assert all. Underneath, this is just a linked hash map, okay? Nothing really fancy, it's actually fairly easy, and thus it's working. JUnit 4.11, actually, you guys are more JUnit people or more TestNG people? Hands up who's more JUnit. Okay, who's more TestNG? Okay. You may want to change the proportions. I hope that after the talk you will be kind of leaning towards it. So JUnit, which version? 4.7, 4.11, 4.12, 4.11. Okay? Most of you? So one enjoyable thing in 4.11, if you ever actually use this sorry excuse of a parametrized runner, which I just highlighted, then you probably know that you need to have fields. You need to have public constructor, which actually injects the fields. And, oh sorry, not this key. You also need to have a parametrized parameters, which are a static collection of object arrays. A very pleasant signature. Now, once you have all that, you also may have parameterized tests in JUnit. Oh, of course, with an appropriate runner. Now with 4.11, your tests might actually look much better in the reporting. Let me actually highlight the relevant part. Okay, so you may specify a name, which is a string, which may contain some markers like index and position of your arguments. Do you know this notation? Shall I explain it? Is it clear? It's clear. Okay. Cool. Let's take a look if there is anything else. Yes, there's one more thing. Soft assertions in JUnit work as a rule, okay? One guy actually coded the rule, and if you use a JUnit rule, aka you need to have a public final field, this public final field needs to be of JUnit soft assertions type, and with that you also may use soft assertions in JUnit. Though, be careful, because if you're using other rules like temporal folder or external resource or expected exception, the order of your rules actually matters a lot in JUnit. Okay? Moving the field up or down, a field annotated with the rule annotation, may actually crash your test without any other change. That's because JUnit rules are made through before test and after test. So what you're actually doing is there is a code inputted in the before test method and after test method. Thus, moving the rules is actually may have great effect. 4.7 brought also a rule called error collector, which has a strange history. For a time it was used as a soft assertion rule, because it collected all the errors. Then it was marked as deprecated. I found no reason in the API for deprecation, at least no comment. Then they actually tried to replace it with soft assertions. However, I don't know how it went out in the end. If you will update to 4.12, you'll actually have one more benefit to parameterized tests, and that is you will be able to use, for example, just object arrays, or just iterable type as the return type for the method which actually creates your parameters. Okay? So it will still have to be public static, but the return type may no longer be the collection of object arrays. Now 5.0 deals away with rules, with runners and number of other concepts, but let's not rush here. Zohhak. Zohhak is the first Polish accent here which I'm bringing in, and this is a simplified parametrized testing for JUnit. In just 3 minutes you will be able to actually tell how it looks. If you spend like 30 minutes, you'll be able to use it quite fluently. Zohhak looks like that. So we have a test with annotation, which is Zohhak stuff. Then we have strings, okay? The annotation actually uses array, okay? It uses array, and with this array, each string is separated. In this case, it's separated by a comma, okay? Here we have a comma, here we have a comma, and same here. And what is happening is that when this annotation is being processed, Zohhak actually splits the string into parameters by the separator. If you dislike the comma because, I don't know, in your strings comma is actually meant for something else, there is the option of changing the separator. It may be a pipe or a semicolon or whatever. You only need to specify this within the test with annotation. Now, what's happening here is so-called coercion. Okay? The word coercion is familiar to you? Okay? Everybody knows it? Nobody knows it? I hear 2 voices for yes. Okay, hands up if you want me to explain it. Thank you. Now this cleared up everything. So coercion is actually forcing somebody to do something, okay? So if I wanted you guys to actually enjoy the streaming, I was coerced into installing number of software here. Okay, coerced is too strong of a word here, but I just wanted to be snappy. So if, for example, a policeman tells you to stop, you're actually coerced by the law into compliance. Okay, the law tells you to stop because the policeman represents the law. So Zohhak actually coerces the parameters into becoming your objects. Because as you can see, while we have strings over here, we have objects over here. Okay, so we have employee, we have money, and we have client type, and these are all types. These are not Java primitives or Java objects or Java wrappers. These are our types. So what you need for coercion to take place is you need to have a constructor which accepts a string and is able to construct your object. Once you have that, Zohhak will be able to use that constructor to coerce a string passed through the annotation into becoming your object injected into the test. So a fairly good and strong concept. Now, the test looks, again, fairly easy. Note that the only JUnit thing we're using is the runner, okay? And now, I may also use, since Zohhak doesn't have soft assertions, I've actually used assert.j to pull out soft assertions because they're fairly nice and work both with TestNG and JUnit out of the box. JUnitParams, another Polish accent here. Yet another runner is of course required because it's after all JUnit. Now then, we annotate our test with JUnitParams parameters. I especially left this here so you know that it's not the usual parameters annotation. This annotation also accepts an array of strings separated by the comma, and what it does actually, it's injecting them here, and then you may actually use fluent assertions to see that the age is okay for drinking beer in United States or Europe. Who can spot the mistake in this test? Oh yeah, that is also correct, but that's my mistake, not the mistake in the test. Nevertheless, you will get something. I'll find something especially for you. So with that in mind, any ideas? So we're taking a number of parameters here, age and the name, and we're actually asserting that age is greater than or equal to yes, I'm not using name. Actually, this is already corrected test because in my previous like few hours earlier I spotted that I wasn't here using or equal to. Apologies. Moving forward, JUnit theories. Hands up who actually use theories on production. Wow, I feel kind of lonely. So, hands up who actually know what theories are. Okay, then you're in a very good room to be. So, what are theories? Mathematical theory says that we may assume something, and once the assumption is met, other things are true. So, in the world of software testing, you're actually specifying number of parameters as input, and you say that all those parameters are satisfying your theory, aka your test, and thus when your test, aka theory, is running, it will pass all those with all those parameters. Have I made it unclear perhaps with my long-winded speech? Perhaps, not so sure. Okay, so let's take you through what we have here. Theories came from Poplar project. Poplar project was a, I think, master or doctorate thesis where a person tried to use logic in JUnit testing. So they came up with two annotations, data point and data points, singular and plural, and they marked fields or methods with them just to use them later in theories. So in order to be able to run theories, what you do is you have that, aka a runner. Then you need to have data point annotated field or a method which is public, static, and returns an array of objects. Now with that in mind, you may create your objects inside, and then you annotate your test with a theory instead of a test. And what it does, it takes every single person field in that test, in that class that you have annotated with a data point, and that is public and static. And it puts it as an argument for this test. So if I had 11 fields of type person, all of them public static, annotated with @data point, all of them will be used as input for this specific test. Now, which is another thing which is actually quite fine is this. With theories, we also have assumptions. So if assumptions are not met, the tests will be marked as skipped. Not failed, but skipped. Which may be different in your reporting, and you may want to react differently to it. Okay? So you have theory. In principle, there is a null accepted parameter, which is a boolean, so true or false. However, I noticed no results for this being actually true or false when I use theories. So in the end, I went with assume, assume not null. Just so you know. So summarizing, TestNG has built in as linked hash map soft assertions. JUnit has either error collector rule or JUnit soft assertions rule. If not that, you may want to actually use assertj, which is a fairly nice assertion prettifier, as I call it, because with assertj your assertions have much more power and flexibility when you use them. If we take a look at how the tests look, then on TestNG side we have data provider or the XML file. Okay, we may use the XML, which is fairly nice to be and configurable without knowing the code. We may of course use data provider, and with that we have in both options we have good error reporting and good grouping of our tests. We may actually only run tests of certain groups, or we may actually run tests in order. Okay, try doing that in JUnit. Now, in JUnit, if you want to actually run parameterized tests, we need a constructor, static methods, parameterized runner, and annotated method, which actually returns proper types. Until 4.11 actually, there is a mistake on the slide. Until 4.11, the reporting of such tests was very, very limited, because the only thing you actually seen was an index of the current set of parameters being passed to the test method. So all you seen on your screen was a bracket, a 0 and a bracket, as a passed or failed test. And then it went on for pretty much every number. So if you passed like 3 sets of tests, you had 0, 1, and 2 as the error reporting and the name of your test. So if you have JUnit 4.11 and you use parameterized test, do use the name in the annotation. Now JUnit is remedied if you use Zohhak or JUnitParams. Okay, both solutions are fairly nice. They work with objects. They're very easy to actually get in and fairly lightweight. Okay, it's like one jar, little dependencies. Both are available on Maven Central. I think JUnitParams was updated last year and Zohhak was updated January this year. So they are still live projects. Finally, when it comes to parameterized testing, we have property testing, of which JUnit theories are predecessors. Now the problem with theories is that they are A, very strict, B, they require that you in your POM actually used Maven Surefire dependency. Okay, so in configuring your Surefire Maven plugin, if you want Maven to run, or pretty much any other build software to run your theories, you will need to play a bit with the configuration of whatever is running your test. In Maven that will be Surefire. I don't recall what's the name in Gradle. JUnit 5. Now February this year was an interesting month because JUnit Lambda crowdfunding campaign actually came to fruition. Okay, they finished alpha version. JUnit 5 as of this moment is unreleased. However, there are snapshots at Sonatype repository and you actually may take a look at them or run them yourself. Alpha release means no IDE support, limited support for Maven and Gradle, however you may run pretty much most of the features, and you only have console runner. So yeah, on the reporting side actually rather poor. However, JUnit people actually also started an initiative called Testing Alliance, if I recall correctly, and they are trying to get all the tool makers for testing to actually conform to same norms. So hopefully if that actually works out, we will no longer have problems with actually using both some tools in the same project. Now, they've actually cut out a number of concepts. Okay, so rule, gone. Runners, gone. Hamcrest tied out so closely to JUnit. It's not entirely gone, but it's actually loosened up. They also introduced the concept of TestNG and test reporting. So TestNG is something that runs your test and it actually passes the data over to test reporting, and test reporting is something that IDEs are supposed to work with to actually display all the green bars, red bars and all the other informations within them. This is actually a significant step forward in terms of cleaning up, because previously every single IDE was on its own when it came to actually integrating JUnit or TestNG. Now TestNG is important because TestNG is a crucial concept if you want to migrate from JUnit 4 to JUnit 5. I'll show you how. There are actually two test engines out of the box. One is for 5th generation JUnit and one is for 4th generation. Now then, from Maven it looks like that. So you're cloning samples project and then you're actually going to Maven consumer directory, then you're running Maven tests, and out of the box you get one test that is kept and two tests that are actually OK. Let me scroll. OK. As you can see, we have first test, JUnit 4 test, and the test that is skipped. And let me show you the POM itself, just so you know how it looks. Number 1. This works with Java 8. Okay? You need to actually have Java 8 to use JUnit 5. Why? Well, they had this lambda in a name for a reason. They wanted to be able to use lambdas in assertions, hence they need Java 8. The other thing, you may want to actually take a look at a snapshot version of JUnit Gen 5, because if you don't, you may actually run into this bug. I haven't tested, I actually took their word for granted. I haven't tested whether the bug is fixed or not. You may do that yourself. Their snapshots are already on the Sonatype repository, and you will need at least 3.1 version of Maven compiler, just so you know. Now this is the dependency, and with this, if you ever were running TestNG tests and JUnit tests from Maven in one go, if you ever use this, or if you use the previous version, JUnit 4.7, which is necessary if you want to run theories from Maven, then you're effectively tying yourself to JUnit. You will not be able to run TestNG tests from Maven unless you switch your profile or do some Maven magic. Okay. The dependency for JUnit 4 will be clear in a moment. Now with that, we may actually run it. And it will report a failure because I've added one more test to show you parametrized tests. Okay. So the test that failed actually should be visible here. The message is perhaps somewhat unclear. And have you used Spock? Yeah, so unfortunately, JUnit 5 still is far behind Spock when it comes to reporting errors. Okay, with power asset, which is a feature of Spock, reporting of an error really is fairly nice. So actually, let's take a look. Can you see what I'm typing? Cool. Now then, let's say that you have an assertion and you want to compare two things. Say you want to compare whether my object dot submitted dot get int is actually same as customer's object some other method getting you a double which is converted to int. Okay, so let's say you have something like that. Now what power asset does with it is it actually shortens this to show you how it looked. So first you get a straight line like that, and here you get some arrow, the other way around, and here you have, for example, that this was a null, and with that you know why it threw a null pointer exception. If it wasn't a null, it for example gives you, say, some representation of the object which if you did not override to string would be, for example, like this. And then it repeats the same for submitted, which perhaps was a null, or perhaps it was not. And so it goes, and when it arrives to actual comparison, it tells you whether it was a true or a false, and it actually takes each piece of your assertion line and it dissects them and it reports it like it. So yeah, this is the power asset features of Spock. Now JUnit 5 doesn't actually fare so well, but still let's take a look at what it has. So I'll take you through all the tests that are in the package. The first test is already a parametrized test, surprise. First take a look at the fact that you have actually different inputs, okay? So awk JUnit Gen 5 is actually for things which are new. Be it API as assertions, or perhaps API as display name test, aka annotations. This test annotation is not the old test annotation, and this is the indicator that we will be using the new JUnit engine. This display name is actually being injected into test via testinfo. Testinfo is a class which holds within 3 fields: test name, display name, and the set of tags. So I could inject here another annotation, tags, where I could set that this test is tagged with fast DB integration, for example. And then if I pass in test info, I'm actually able to run an assertion like this, that this is something that we get as a display name. And ta-da, I'm lazily evaluating this message. So if constructing of an error message was costly, you may use lambdas. Wow. I see that you guys are thrilled. You cannot wait to use it in production. My sentiments exactly. If you wish to ignore the tests, no longer possible. Now you may disable the tests. Don't ask me why, perhaps for naming reasons. And if you want to run a JUnit 4 test, you need to actually choose a different annotation and choose a different assertion. Okay, so you need to watch your inputs, in short, if you migrate. Now, the test I've tried to add was to take a look at what can I actually do with grouped assertions, because JUnit 5 has them. Okay, there is a method asset all, which takes a name which will be used in reporting, and then this name is used to report failure of this assertion, that assertion, and pretty much every other assertion that we use. You may actually even chain lambdas here. For example, yeah, notice the message, it's the same as we've seen in Maven. Testinfo is rather poor way of having parametrized tests, but this is what we get like out of the box. The other way to inject parameters into JUnit methods in JUnit 5 is to extend one JUnit class, custom verifier. If you do so, you're able to actually write your own object that you will later be able to use as sort of parameter injection. Unfortunately, I found that to be less interesting than what TestNG allows me to do or Zohhak allows me to do. I found actually that reading Zohhak tests or TestNG tests is much nicer for me because I see precisely what I'm injecting. I see whether I'm injecting employee and money and something else, and putting this all in one object, even if I name this object really well, doesn't get the same effect. At least for me. Perhaps for you it will. We've already run it. So this covers actually majority of what I have on parameterized testing. Any questions so far?
Thank you. Okay, I have just one question. This conversions between strings and objects. So you've told for Zohhak that you can have a constructor which creates string. If you cannot have this kind of constructor, do you have any alternatives?
If you cannot have a constructor, from my brief encounter with Zohhak's code, it wasn't actually very long. It like took 2 hours or something like it. Mm-hmm. I think that if you had a factory method, you would be able to do something like it. Also, you may actually write your custom coercers. So your own methods which actually will do the trick without the constructor but with something else.
Okay, I see. Yeah, I'm personally a JUnitParams user. So And maybe another question. This soft assertions. Quite often with some parameterized tests or some kind of this stuff, it's very difficult to tell which one has failed. So among all, what are the situations there? What is the situation?
Without being... just give me a moment. Okay, here we have soft assertions. We run this test with TestNG, and now you can see that Tommy is not of age in Europe and Tommy is not of age in US. Sioman is also not of age in US, and he's also not of age in Europe because he has 18, and I used yeah. So this is the mistake. Finally, for Miriamela, you can see that only the US assertion actually failed. This is how TestNG reports it. Do you want me to run it from Maven?
No, I believe we'll
the reporting is fairly similar.
Yeah.
When it comes to, let me take a look whether I have actually. No, that's not it. That should be it. Okay. Now I'm running. This is the JUnit soft assertions with asset J. So here the reporting actually comes from asset J.
Okay, and maybe just a clarification. And how? What is your attitude to this kind of soft assertions in the assumption that at least one of the paradigms that is imposed on tests, that there should be only single reason for tests for fail?
So my attitude is that in number of cases we're actually fairly good with just what JUnit offers out of the box. Okay, so we will not run parameterized tests, we will not chain our tests will be isolated, independent of each other. One test will be one execution unit, and it should be actually so. And thus you don't need rules, groups, filtering and all that, and soft assertions as well. However, in some cases your object has a state, and the state needs to change like at the same time. So if I change the bank account, my bank Swift code should also change. And thus I need to assert that both changes happened. And if I do it just by one assertion, then I'm actually splitting the business meaning into two different tests, which may be problematic at a later point. And this is where soft assertions actually come really, really handy.
Okay, thank you.
Not a problem. Excellent barrage of tests, of questions, sorry. Guys, if you want to actually win a t-shirt, this is a great way. Anyone else? Shoot.
Sorry,
Whoops.
it might be not in the main thread here.
Mm-hmm.
Honestly, a big fan of testing, and I'm been testing for a long time now. And actually, I'm missing the why so much efforts you guys playing in building a way for having parameterized test methods. In most of cases, I face it with so far, I was able to run several independent tests, and they, I mean, an example you provided us, for example, with the ages when it's legal to drink alcohol.
It's a fairly silly example.
You can just have, you probably will end up with having 5 tests methods rather than one parameterized, but it will be very easy to support, easy to read, and probably I'm missing something, guys, here. Could you please provide me a good example where it's real worth to pay so much efforts on supporting this?
Let me try. So First case when I ran parameterized tests out of my own volition was when I actually created a solution for mapper injection. So we had a number of DTOs, and very often DTOs would actually use mappers to transform between the entity and the DTO. Now those mappers were fairly repetitive code, and thus I decided that I can use Spring to actually make it simpler. I could use Spring and I could actually have those mappers auto-injected via component scan. But for that I needed to make sure of a couple of things. Namely, I needed to make sure that the mappers were in appropriate package, because my component scan was limited to this package. Thus, I needed a mapper that was outside of the package, and I needed the set of mappers that were inside of the package, and then I needed a set of mappers which were strange enough that my solution would not help them.
Okay.
And if I were to just create a test for a mapper, that would be fairly silly, because I would just tie my code to the name of mapper classes. So I wanted a method which actually grabs all the mappers, and hence parameterized testing came to be of use. If you do not feel that you will benefit from actually having parameterized testing, that's okay. Just don't use it.
Yes.
However, in number of cases, we do not use parameterized testing because we do not know how.
Yeah, it's my big case, but I mean, it sounds like I'm only a person who doesn't see any benefits of it. I'm just wondering that we are providing following this approach, we're providing a way for a guy who is not, very familiar with the testing in general to test much more than we have to. For example, in this particular case, what we really have to test is our ranges. Yeah, before have a test when a person has a age less than 18 in Europe, between 18 and 21, and more than 21.
Let me offer you different examples then of
Please.
parameterized testing. I had a production failure. A number of data of my customers might have been corrupted.
Mm-hmm.
Now I need to know whether they can log in. So I'm running automated tests which takes users of database and tries to log in.
Oh, I got it. In this case, yeah, we're dealing with not like a unit test. It's more about reproducing, using the tests engine for helping us to reproduce then production.
The task at hand
error.
was to actually solve the problem that came from data being corrupted. If I wouldn't test my solution, I wouldn't feel good about it. The other case for parameterized testing, release happens. It's Sunday, 5 p.m. Me and my friends are already rather tired. It's like the other second day of a release. We're working in shifts, and right now we're actually ironing out bugs. And there is this bug in Hibernate, actually, in the old version of Hibernate, that if you do not split your list of arguments for in clause in SQL query, it will crash after it reaches 1001. Because for some reason somebody thought that nobody will ever have more than 1000 arguments in an in clause.
Okay, I got it. I faced it with this issue. Okay.
And now I have number of parameters that I can have for input. 999, 1, 1001, 1000, and those represent various border cases. I may of course create 5 or 7 tests for those parameters. And I may name those tests and copy paste the code. But it's actually the same test over and over. The only thing that it's different is the input. So I would say you will still arrive at the cases when parameterized testing will be of use. Just keep an eye on it and it will come. Any other question? Okay. So moving on. Non-functional requirements. Extensibility, configurability, modularity. These are perhaps similar, but not the same. And very often, when people have those as non-functional requirements for the system, they are not really sure how to test them. Okay? How do we test that our system can be quickly and easily modified? How do we actually see whether we can update the configuration on the fly? And things like that. So how do we do that? What kind of tests are that? So these are system tests. Okay? System tests are something that actually make sure that across your system some requirement is being met. Now, some examples would be that ignore on your tests is not being abused, that people do not make a quick fix like, I'll ignore those tests for now because I'll fix them later, and then later never comes. Or another example, for example, you have REST annotations and you want your paths and names of your REST services to follow certain convention. Or you have an integration with client A which needs to follow certain conventions. All that. These are system tests. Now, you may do system tests in a various way. You may do them from the script, you may do them from Maven, from your build tool, continuous integration, number of ways. You may actually have Sonar flag the violation and actually fail the build if you want. That's another option. And there is also something which is called class path scanning. Hands up who knows the term. Okay? So for other people, class path scanning is when you're actually actively taking a look at your class path to see whether certain classes are there or are not there, and whether, if they are there, they meet your conditions. Like, for example, that if somebody put an ignore annotation on your test file, or test meted, then he also wrote the date. And he also wrote the reason. Like, I'm ignoring this for 2 weeks because the author went for vacation and we urgently need to deploy this. This is a corner case documented in this and that Jira. And with this, we can see that, okay, we have a date. We have a person who touched it. Once the date comes, this person needs to actually do something about it. If he doesn't, we may actually fail the build. Now, class path scanning has like more than 10 tools. Spring does it, JE does it, Java Assist does it, scannotations, reflections, CPRS, and a number of other tools do it. They are faster or slower, but still they need to parse your entire class path. And that's no mean feat. Okay? Take a look at just your simple Hello World application and try to weigh your class path there. Just the RT jar has like 40 megabytes. So your code, in order to work with class path scanning, needs to parse at least that. So I want actually to change your way of looking at it by yet another Polish accent, haha. And this time it's class index. It comes from Toruń. Toruń also has very nice pierniczki. Gingerbread is the English word. So it should be a really sweet library. So what does it do? Well, class index doesn't scan your class path. It actually indexes your classes on the compile annotation phase. So whenever your annotation are being processed by annotation processor, another output is outputted, which actually tells you where is your class and what info does it have. And with class index, you have number of things you may do. For example, you may annotate a type and all subtypes of this type will be indexed by class index. So you will see whether your object hierarchy conforms to the norms. You may annotate annotated classes to actually see that yes, this test is actually this entity actually has all I need. And you may even check Java docs if you so desire, because there is a way to store Java doc information once you index the class, and thus you have pretty much everything that class path scanning gives you. Now, the times are actually taken quite some time ago. Feel free to go to their GitHub because that's taken from their README page. Oh, what a nice effect. Never knew I could do that. Let's see if actually this will help. Seems to have done the trick. So, you may see that the times for just hard-coded list of classes is actually the same as for class index for the application startup. And this is fairly important because if you're using system tests, then probably once your test is up and running, in the setup method or in the before class or whatever, you've actually trying to access your class path and scan it, which takes quite some time. And if you want your feedback loop to be short and quick and to the point, you don't want that time. So thus, think of class index as an alternative for class path scanning, and whenever you want to actually run system test, take a look at the library. Okay. Usability, aka how your users perceive your system, whether it's actually being of use for them and what you can do here. There is one tool, unfortunately I didn't manage to get the demo done, but if you do not want any toolings, or you may not have any toolings, you may want to actually think about scenarios. Scenarios are a very good way of testing pretty much any non-functional requirement, any at all. It is a testing method which relies on knowledge in the team. So say myself and those 3 people are in a team. We actually created a feature. Now we want to know how much reliable the feature is. So we're going together to a room and we're shooting a question at each other like, what would happen if, for example, this database would go down in flames? Would our software still be able to perform? And we will be brainstorming like, well, it would be hard. I don't know whether the annotation would manage to actually grab the metadata. And we would speak in technical jargon for each of the parts of the feature we actually did. And together we would come up with the answer. Like how probable is that the database coming down in flames actually kills our feature. And if it does, what can we do to remedy this? So with scenarios, you're able to actually come up with a test for every single non-functional requirement. Of course, when you try to code those tests, these are end-to-end tests. So tool number 1 is given Selenium. The other tool is Gauge. Gauge is an alpha tool which I haven't yet tested, so don't take this slide as a recommendation, go and put it on production. It's not. However, you may actually take a look at it because ThoughtWorks is trying to push it as some sort of a Selenium helper or a platform for it. Okay? So if you actually have problems with Selenium in your company, you may want to take a look at Gauge. Number 1 scenario for usability. How hard would it be to add an undo feature on a given screen? So say you have choose items to the cart. How hard would it be to undo, and whether the undo would be for last item or for the whole cart? How hard would it be if I, for example, just clicked, yes, hire this person? How hard would it be to actually undo this? This is one of the most common scenarios for usability testing. Performance software. So high availability, the ability of our software to still be of service for our users despite whatever trouble is brewing. And reliability, which is not only our software is available, it also performs whatever service it is supposed to perform. Now with that in mind, there are 3 types of tests. There are load tests, soak tests, and endurance tests. Important distinction. Load test you do if you're actually measuring that the ceiling you predicted for the traffic is actually something that your infrastructure application, all of it together, can handle. Okay, so you're anticipating that in your peak you will have, I don't know, 100 concurrent users per second. And now you're actually running 100 sessions per second concurrently to see whether something crashes or not. These are load tests. Soak test is when you actually breach the ceiling. You no longer have 100 concurrent users per second, you have 102, 105, and you keep increasing. Soak tests is the information how much damage can my software take. And finally, you have endurance tests, like I'm running within the predicted ceiling, within the ranges I said my application can handle, and I keep running close to the upper border for an hour, 2 hours, 4 hours, 2 days, 2 weeks. These are endurance tests. Now there is tool number 1, which is fairly interesting, Stress. It's a command line tool, and the other is Gatling, which is a Scala library. So to have a command line tool in Debian, it's just sudo apt-get. Then I would suggest you to run man to read. It's like less than A4 page, 1 sheet of paper, really. And then run hatop and play. It's not here. It's actually too many windows. Where is my Tmux where I need them? You guys used Tmux? Yeah. Fairly nice software, isn't it? Yeah. Okay. So this is HTOP. HTOP currently is showing that my 4 cores are doing, well, not much. My memory is mostly empty, and I have nothing on my swap, luckily. It also shows us that there is like 2 running tasks. You don't see anything here because it's already sorted by CPU and filtered by command used, just so we'll only see the relevant features. Now then, let me run this command. What I have here, I'm stressing my CPU with 4 workers, my I/O with 3 workers, my hard drive with an additional 3. Then I'm doing allocation of virtual memory with additional 2 workers, and I'm allocating 128 megabytes of memory. What will actually happen? Stress will fork several processes. 4 of them will be forked just doing square root on a CPU. Yet another 2 will flash my I/O with sync call. Then yet another will actually try to write to the disk and read from the disk in an endless loop. Yet another will try to allocate bytes. You may even try to cause page faults if you want. There is a VM stride parameter, so you will have also that option. By default, if you don't specify this, it actually allocates 256 megabytes of RAM. Okay, ready for enter? Enter. And here we are. Okay, now you can actually take a look. Already my system is in high mode. You can see that we have like 8 running processes right now, 12 now. These workers may not use the CPU at the same time because I gave a larger number of workers than I have the CPUs. Now, all the CPUs currently are maxed out, and once this happens, my machine's resources are hogged. And now I may try running my application and see whether it will start up and perform. So fairly easy to do on a pretty much any Debian machine. You may actually flip it, run your software, flip it out. If you wish to actually test it in moderation, You may do so. Right now it will run at infinitum or until I kill it. But just doing this and adding timeout, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I could actually practice my Russian here. Sorry for missing the occasion. So 11 seconds total, 1 second for forking and dispatching all the workers, and then we're ready. Yep. Fairly simple, fairly nice tool. Now then, let me move to something even more interesting. Time is running out? Okay. Okay. So, the next item is Gatling. Gatling allows you to record your tests via clicking. Gatling is... Who used JMeter? Forget about JMeter. Use Gatling. Totally. No matter that it's in Scala, or for some people, wow, it's in Scala, we need to use it. JMeter is outdated, okay? It was created in like early 2000 when Apache was not even a thing, okay? Apache was not even a thing. JMeter was created when another web server was actually being constructed, and it was created to measure that server. Then the server didn't work out because of Apache, and JMeter is like not really made better ever since. But oh, sorry, not this, this. This is actually a reporting done by Gatling out of the box. I've recorded myself walking on a page. Then the result was actually written down to this. Okay? So over here I have a Scala code which I may fully tweak and change, and I may compile it from Scala REPL or IDE. I may run it from Scala REPL or IDE, and with Gatling you're able to actually run what, 30,000 requests on a single machine. With JMeter you're like killing your machine with 4,000. It will not scale past that. So if you want larger traffic, you need more machines. And moving on, last part. DataBene Benerator, actually, you know what, let's skip to this. So what we have here? Come on. This is Infinitest. Infinitest allows you to continuously run your test whenever you press save or whenever save happens in your IDE. Whenever that happens and all the files you touched, if they have relevant tests, those tests are being run. So great tool for developers. Zohhak, JUnitParams and JUnit we covered. JUnit Lambda we also covered as a TestNG. Now here you have Gatling and Stress. Then DB part, which we didn't manage to cover. jFairy and DataBene Benerator are fakers, okay? They will create you fake data. They will actually create you a fake person, fake user, fake student, fake whatever. You may run these guys from Maven, from Gradle. You may run them from your own IDE, and this allows you to test with, for example, load tests or stress tests with real, well, quasi-real data. DBUnit is the JUnit for databases. This logo is actually Spring Data. If you have DAO, this tool is great in simplifying your tests because it will actually generate the DAO for you. Byteman is a tool for fault injection. You're actually injecting bytecode into specific places where you want them to behave as your monitor or fault causer. You will actually be able with this to see how your software will behave if a null appears over there. LiquiBase is a source control for database scripts. for schema, for grants, for user permission, for tables, for SQL syntax things, pretty much everything. WireMock is a tool that allows you to mock a server so that you can test your web services in isolation. Okay? They will still go out, they will reach your mock server, they will come back and report whatever they need to report without walking through the network. Awaitility. This is incredibly useful if you're doing asynchronous tests, concurrent tests, or if you need timeouts in a real manner. And that is it. Thank you very much.